Team, it's Mr. Z, and today we're going to talk about connecting potential equations to a graph, and we're going to flex the opposite muscle. We've been practicing writing equations. We've been practicing taking key information from an equation to make a graph, but now we're going to go vice versa. So let's go ahead and just kind of put all of this stew together. So basically, I'm given a graph, and I have to analyze whether or not these equations could be a potential match. So when I'm looking at this, I'm going to just look at the graph and identify some key information. I notice that it is concave down, which means that A is going to be a negative number. I know that it has two zeros that are both going to be a negative number. So, for example, I know that it's going to be x equals negative 2, let's say, x equals negative 4, and then this is going to cause the factored form to look like x plus 2 and x plus 4. I also know that if I continue this graph long enough, that it will hit the y-axis, and the y-intercept will be a negative value, negative 10, we'll say. And all of these numbers are flexible because there are no labels. But if any of these are invalid, then the equation is not going to be a good representative. I'm looking at number 11, and I see that A is a negative value. And I also see that the zeros, x plus 1, x plus 4, when I set them equal to 0 and solve, both of them have a negative x-intercept. This is good as well. I think this is a good match. Why? It matches the concavity and the x-intercepts match the graph. Function number 2, again, it's concave up. I'm going to go ahead and just look at all of these right now. Looking at the first term, looking at the a value, even though there's no number there, it's a negative 1. And I could immediately say that this 3 guy is not concave down. So it's going to be disqualified. Not concave down. Disqualified. Not concave down. Disqualified. All right, going back to 2 though, I see that the y-intercept, since it's in standard form, is 0, negative 6. Since it is concave, the concavity matches, and the y-intercept can fit, this is a good fit. Now, jumping to 6, I see that this is in the vertex form, and this graph has a vertex, which is 6, 3. Remember, when you're looking at vertex form, it's always x minus h plus k. Now I'm looking at it, 6, 3, 6, 3. So I would have to go over to the right and then go up. This is saying that the vertex should be in quadrant 1. This is not the case. So this is not going to be a potential option. Looking at the next one, number 7, I see that the zeros are at negative 2 and at 3. And this is disqualified because both x-intercepts need to be negative. Okay, this final guy, again, has me, I'm going to relook at this formula as if it was negative 1 times x minus 6 squared plus 3. And this reveals that the vertex is 6 plus 3, negative 6, positive 3. And if this means I go to the left, negative 6, and up 3, this is a possibility. So the vertex and concavity mean this is an okay graph. This is meant to be just a tease. It's an exercise for you to look at multiple equations and reinforce what you already know. So go out there, practice 12, practice 13, and come on back.